everyone. I am Rekha, Assistant Professor in Pandit Nekiram Sharma Government College, Rohtak. Today I am presenting the topic from dynamics in the central orbit, and the topic of my presentation is apse and apsidal distance. First, I will define these two terms, apse and apsidal distance. What is apse? An apse is a point in the central orbit at which the radius vector drawn from the center of force to the point has either a maximum or a minimum value. I will explain it with the help of an example. Let C be any curve ABC. These are 3 points on the curve. Let A be C. These are the 3 points on the curve. Let's O is the center of the force. I will take this distance 2 cm, 3 cm and 5 cm. As we've seen from this figure, this distance is 2 minimum distance and this distance is 5 maximum distance. It means the point A and C, these are the apse, and the angle between the apse is known as apsidal angle. And what is the apsidal distance? The distance between the center of force and apse, that is known as the apsidal distance. Means the distance between O and A, O and C points, this is known as the apsidal distance. Again, we take the example of a circle. We know that the distance from the center of force to any point in the circle is always same, hence all the points are called apse in case of a circle. Next, I prove the theorem. And what is this theorem? We have to prove that at an apse, the apsidal distance and the tangents both are at right angle to each other. For this proof, I will take another curve C, and this curve is C. A is a point at which A has an apse. O is the center of the force. Let's do an perpendicular at the point A. Center of force to the point A has the radius vector r. Now for an apse, we know that the distance from the pole have either a maximum or a minimum value. Also, we know that in case of central orbit, there is a relation between u and r, and which is equal to u is equal to 1 upon r. R is the radius vector. If r has a maximum value, then u is minimum value. If r has a minimum value, then u is maximum value. Since u is a function of r, therefore its derivative with respect to theta is equal to 0. Also, we know that for a curve, the Pedal equation is 1 upon p square is equal to u square plus du upon d theta whole square. Using the value of du upon d theta and u is equal to 1 upon r in this equation, and after simplification, we get p square is equal to r square. This implies p is equal to r. Also, we know from the calculus that p is equal to r sin phi, where p is the length of perpendicular from the center of a force to the tangent at P. And what is this phi? This phi is the angle between the radius vector and the tangent at A. By using the value of P is equal to R sin phi in this equation, we get sin phi is equal to 1. This is only possible when phi is equal to pi by 2. Again, I will consider the case of the topic from the velocity at any point on the curve. The velocity at any point of the curve is denoted by v. If we have know the center of the force, means if we know the value of the f, then we can easily calculate the velocity at any point on the curve, where c is the constant of integration. Now velocity from infinity. The next topic is the velocity from infinity. When a particle moves under a central force, the velocity that it would acquire if it is moved from rest at infinity to that point is called velocity from infinity, and the formula is given as v square upon 2 is equal to minus integration infinity to a f dot dr, where f is the center of force. We can easily calculate the value of v velocity from infinity to that point at an apse. With the help of the following example, I will calculate the equation of the curve. If it is given that the central force is equal to this and velocity from infinity at an apse at a distance, then we can easily calculate the equation of the curve. We have to find, in this example, find the equation of the curve. For finding the equation of the curve, let's we first find out the velocity from infinity. by using the formula which I have already discussed. V square is equal to minus 2 infinity to f dot dr, and after simplification we get the value of the velocity from infinity. Also we know that the differential equation of the central orbit in the polar form is given as this: h square into d square u upon d theta square plus u is equal to f upon u square. Putting the value of f in this equation and multiply, for simplification of this equation we have to multiply both side by 2 du upon d theta, and after integrating we get equation 1. For finding the value of the constant c, again I have using the initial condition. We know that at an apse u is equal to 1 upon a and du upon d theta is equal to 0. Also v square is equal to v square. This is the velocity from infinity and this is the velocity of the particle v. This is equal to mu upon 3a square. We have already calculated from the previous. After simplification we get this equation. Now from first and second I have calculated the value of h square. This is equal to mu upon 3a raised to the power 4. From second and third we have find the value, from first and third we have find the value of c1 is equal to 0. Now again putting these values in this equation 1, and after simplification we get this equation. Since we have given the value of the force in terms of r, therefore again using u is equal to 1 upon r and du upon d theta, we in this equation after simplification we get this equation. Now using du, separate the variable, and after integrating we get the required equation of curve. Again using initial condition, because there is a constant c2, for using initial condition r is equal to a, theta is equal to 0, we get the equation of the curve which is we have to solve out.